Welcome to today's class. In the today's class, you will see the topics related to continum, and that means continuous matter concept, and reversible work and problems. Okay, these things we will see in this class. In the last class, we covered the different concepts related to system, surroundings, boundary, next process, path, thermodynamic equilibrium condition, next one quasi-static process, reversible cycle, irreversible cycle. Okay, these we completed in the last class. Now we will see the concept of continuum. Okay, the concept of continuum. Okay, continuum. Okay, that indicates a continuous matter. Now, so in the mechanical engineering, we consider a particle size which is more than the molecular level. Okay, if we consider a small volume, it is very bigger than the molecular size. Okay, we consider a statistical average of a property, and that property we consider for that. Okay, and that is called as a macroscopic approach. We are not going up to the microscopic level or molecular level, but we consider statistical average of the property, and that property we are consider for entire system. Okay, what we consider. That means up to that volume or up to that system, we consider that the matter is continuous. The matter is continuous. Right. Now, I want to explain that concept with a small example. Suppose this is the considered system. Okay. And this is having a number of molecules inside. Okay, let us assume this system volume is V, and it is having mass M. Okay, but inside the system I want to consider a point P. Okay, this is point P. Okay, and around the system I want to consider a small volume of delta V. Okay, and inside the small volume it is having mass of delta M. Okay, now delta M by delta V, it will gives us delta M by delta V. It will gives us a density. Okay, the small by considering small volume and a little bit of mass of molecules, we consider that density. Right. Now this volume is shrinks towards point P. Okay, ila shrink avutundi anukunda. Okay, in such cases what happened, the molecules which are present inside the volume, it may come closer, and density delta M by delta V may increase. In other words, when the volume shrinks, the molecules which are present there, they may come out of the volume. Okay, one instant is due to the shrinkage of volume, the molecules will come closer, then density will increase, dou M by dou V may increase. When it shrinks, sometimes the molecules which are present there, they may come out of the volume. Okay, in such cases density may decrease, but if we goes on increasing the volume of considered small particle, if it is increases, at particular volume level, the change of delta m by delta v, it is negligible. It will always gives a constant value. Okay, in other words, we can say after crossing a particular volume level, delta m by delta v reaches an asymptotic line. Okay, or in other words, we can say at that particular point onwards, the matter we can consider as continuous, and it will give the statistical average of all the properties. Therefore, that property we can implement for the total system. Okay, that type of consideration we are taken for the macroscopic thermodynamics. Okay, this concept is called as a concept of continuum. Okay, concept of continuum. Okay, that means the matter is continuous, or properties continuous, properties are uniform, right? Now I will draw the graph for that. See, let's assume this is an asymptotic line. This is an asymptotic line, and delta m by delta v. Okay, density I considered on the y-axis. Against volume, I want to draw directly volume I considered on the x-axis. Right. Now, initially, the volume V I considered at this portion. Okay. Right. Now, the volume delta V shrinks. Okay, when it shrinks, the molecules may come together. When it comes together, the density will increase. Okay, that means this will increment. It will increase like this, right? Suppose the volume shrinks, sometimes the molecules which are present inside the volume, they come out. Okay, then the density will decrease. Okay, the density will decrease. But the volume continuously increases, delta m by delta v, it approaches the asymptotic line like this. After that, it gives same value throughout the considered system. Okay? Therefore, this is the limit. This is the limit for microscopic studies and macroscopic studies. Okay, that means if you consider statistical average of the properties, in this region you are studying, this is the macroscopic relations. Okay, macroscopic relations are valid in this region. Okay, macroscopic relations are valid in this region. But in this region, microscopic studies you need to do. Okay, microscopic studies you need to do, because this density and everything that will vary. Right? Properties vary at the molecular level. Right? That means this point onwards, we consider it is matter is continuous and statistical average of properties are obtained. Okay? This is called as a concept of continuum. By considering this concept of continuum only, all the properties we consider in the thermodynamics. Right. Now I will explain another concept that is irreversible work. Reversible work. Okay, in the last class, we see irreversibility always present. Irreversibility always present. Okay, due to internal viscosity, internal hypogeous motion of the molecules, and external friction and heat transfer in the form of radiation, in such a fashion irreversibility is present. But if you consider reversible work, we need to idealize the system. There is no heat loss from the system, or there is no heat enter into the system. Okay, and while doing work, there is no loss of work due to friction. Okay, and internal viscosity also we idealized. Okay, in such cases we can consider the reversible work. Okay, to explain that reversible work, I want to consider a cylinder and piston system. This is the piston, right? Cylinder and piston, and this piston is attached to a connecting rod, right? Now this is the air which is present inside, okay. Now the friction in between the cylinder and the piston is neglected. Piston and the cylinder friction is neglected. Okay, and it is completely reversible. Okay, that means there is no loss of energy, and which is not irrecoverable. In such a fashion, there is no loss of energy. Okay, now we will consider Q amount of heat energy is supplied to the inside air. This is the Q amount of heat energy that is given. Due to the given heat energy, pressure P is applied over the piston surface. Okay, here due to the heat energy given, the air which is inside, tends to expand. Okay, once it tends to expand, it applies the pressure over the piston crown. Okay, therefore the amount of pressure applied over the piston crown, that is P equal to pressure on the piston crown. Pressure on the piston crown. Okay, now the cross section of the piston, or the cross section of the cylinder, let it be A. Okay, the cross sectional area A is the cross sectional area. Cross sectional area of the piston or cylinder of piston. Okay, now we can say pressure P is acted over the piston crown, and A is the cross sectional area of the piston. Then what is the force acted over the piston? The force acted over the piston equal to pressure into cross sectional area. Okay, the force F acted over the piston equal to pressure multiplied with the area. Okay, now when it is multiplied with that area and that force is acted over that, the piston has a displacement of delta x. Okay, and కొద్దిగా move అయింది అనుకుందాం. Okay, for the sake of convenience only I consider this delta x distance here. Okay, it moves for a distance of delta x. Okay, right. Then what is the work done over the piston? Okay, the work done by this force over the piston equal to force multiplied with displacement. Okay, that means work done equal to force into delta x, that is equal to pressure into area into delta x. Okay? And this delta x, the limits of delta x, initially if you consider it is at 0 position, and after the movement the extreme last condition or extreme end condition, that is equal to stroke length. Stroke length ఎంతైతే ఉందో అంతవరకు వెళ్తుంది, అంటే 0 to L, 0 to L. Up to that we need to be integrate. Okay? Integration within the limits of 0 to L. P into area into delta x within the limit 0 to L. Here delta x we can use delta x, x also 0 to x. Okay, that is the total displacement. Okay, now I want to just modify it. Okay, in terms of volumes, area into delta x, that will give us delta v. Okay, area into delta x, that will give us delta v. Okay, therefore this is the integration of pressure into p dv. Okay, dv. And what about limits at 0 length? Okay, this is volume v1. Okay, this is volume v1. After the displacement up to here, this is the volume 2, v2. This is v2. Right. That means the limits will be v1 to v2. Okay, W, the reversible work W is equal to integral PdV within the limits of V1 and V2, initial volume to final volume. Okay, this equation every student should remember. Wherever the work done, okay, reversible work done occurs, we need to use this formula. W equal to integral PdV within the limits of V1 and V2. And here the reversible work, that is the reason the friction, it is 0, and there is no work or heat loss in the form which is not recoverable. Okay, recoverable చేయలేని అంటగా heat గాని work గాని loss అవ్వదండి. Okay, everything is recoverable. That is the reason it is reversible. Right? This is work equal to integral PdV V1 by V2. Now you will see different problems on this equation. The properties of a closed system, the properties of a closed system changes as following relation between pressure and volume as PV equal to 3.0, right? And pressure is in bar, volume is in meter cube. Okay, pressure is in bar, volume is in meter cube. Calculate work done where pressure increases from 1.5 bar to 7.5 bar. Okay, now we can write initial pressure as P1 equal to 1.5 bar, right? P2, that is equal to 7.5 bar. Okay, and we need to calculate what is work done. In this problem, it is reversible, irreversible. Those terms are not mentioned here. If it is not mentioned, directly we can consider that as the reversible work only. Right. Okay. Now, in the reversible work done, then it asks to find reversible work W equal to integral P dV within the limits of V1 and V2. Okay, V1 and V2. Okay, likewise it is given, but the given parameters are P1 and P2. Okay, now we need to express this P term in terms of volumes, then only it will be satisfied, right? Now, what is P1? P1 equal to 1.5 bar, but this one, here you can see PV equal to 3, right? PV equal to 3. Suppose P1 equal to 1.5 bar, then V1 also equal to 3. Okay, that implies V1 is equal to 3 by P1. Okay, 3 by P1. 3 by 1.5 bar. This is volume. Okay, it will gives the answer in meter cube. Right? Next, consider the second one. Here, PV equal to 3 for that also. Therefore, P2 V2 also equal to 3. That implies V2 is equal to 3 by P2. Okay, 3 by 7.5. Okay, that will give in meter cube. Right. Now we need to substitute these things in the equation. Right. Now this pressure is in bar. Therefore, W equal to integral. These values I can write. V1 by V2. Pressure is in bars. Okay. Therefore, we need to take 10 to the power of 5 here. And P we can express as 3 by V dV. Okay. Now everything will we can substitute there. Okay. Now I will note down the 3 by 1.5, this will give us 2 meter cube, and this is 0.4 meter cube. Right? Now, if you integrate this, integral 1 by 3 by V, 1 by V equal to log V. Okay? Therefore, 3 into 10 to the power of 5 log V base E within the limits of this V1 and V2, that is 0. The integration and substitution of these values, the final answer will be minus 4.828 into 10 to the power of 5 joules. Okay? We can write in the kilojoules, minus 4 kilojoules if you want to write 10 cube, right? .828 into 10 square kilojoules. Okay? And generally student did mistake at this point. Okay? They forgot to write 10 to the power of 5 because one bar equal to 10 to the power of 5 Newton per meter square. Okay, 1 bar equal to 10 to the power of 5 Newton per meter square. Here pressure is in bars. అంటే ఇక్కడ ప్రెజర్ సబ్స్టిట్యూట్ చేసేటప్పుడు బార్స్లోనే సబ్స్టిట్యూట్ చేయాలి. కానీ బార్స్లో సబ్స్టిట్యూట్ చేయాలి అంటే మనకి ఇనీషియల్ ప్రైమరీ యూనిట్స్ న్యూటన్ పర్ మీటర్ స్క్వేర్ మీటర్ క్యూబ్ వీటిలో తీసుకోవాలి. కాబట్టి 10 to the power of 5 ముందు కూడా రాసేస్తామన్నమాట. Okay, here also while doing the substitute in this log 0.4 minus log 0.2, that equal to log 0.4 divided by 0.2 base e. Okay, that will give this answer. Right, student need to check the answers and they need to do the problem individually. Right, and you may ask why the minus sign is occur. The minus sign is occur. Now observe. Pressure 1.5 initially and pressure, final pressure 7.5. Pressure increases. When pressure increases, volume will decrease. Okay, that means incremental direction in this direction, but in the direction of increment it is decreasing. That is the reason it is a negative sign. Okay, right. Now we will go for another problem. Note down. To a closed system, 1.5 kilojoules work is 150 kilojoules. 150 kilojoules work is supplied. Okay, work given as 150 kilojoules. It is supplied. Right. If initial volume is 0.6 meter cube and pressure of the system changes as P equal to 8 minus 4V. Okay, a governing equation is given. Okay, pressure of the system changes as P equal to 8 minus 4V, where P is in bar and V is in meter cube. Determine the final volume and pressure of the system. Okay, now note down the given data. Pressure of the initial volume of the system V1 is equal to 0.6 meter cube. Right? Next, and pressure of the system changes as a governing equation P equal to 8 minus 4V. Okay, and P is in bar, V is in meter cube. Okay, this condition is given. Next one, determine the final volume of the system. Okay, final volume of the system. V2 asked to find, and final pressure of the system P2 asked to find. Okay. Here V1 is given. Once you know the W is given, W is equal to integration of P dV within the limits of V1 to V2. Okay, V1 we know and V2 we don't know. Okay, right. After that we can find the what is V2. After that we can substitute V2 in the equation. We can find the P2. Write the equation. W is equal to integral V1 to V2 P dV. Okay, therefore integral V1 equal to 0.6, V2 we don't know. Right, P equal to 8 minus 4V and dV. Okay, is it right? Okay, now W that is given. Substitute W 150 into 10 cube we need to write. Okay, kilojoules. Right. Now equal to integration of 8 minus 4v. 8v minus 4v square by 2. Okay, within the limits of v2 and 0.6. Right? Now you need to substitute v2 here and 0.6. Okay? After the substitution and subtraction, you got this as v2 as 0.86 meter cube. Okay? Mathematical calculation you need to complete. Right? 0.86 meter cube. Once you got the v2 value, directly you can substitute this v2 here. P equal to 8 minus 4v. Okay? 8 minus 4 into v2 0.86. Okay? That will gives us P2 equal to 4.56 bar. Okay? మనకి P1 అడగలేదు, ఒకవేళ అడిగితే డైరెక్ట్గా సబ్స్టిట్యూట్ చేసేస్తే P1 కూడా వస్తుందండి. రైట్? In this way we need to do the problem. We'll do one more problem. Note down. A fluid at a pressure of 3 bar. Initial pressure, this is given. And with specific volume 0.18 meter cube per kg. Okay? That means kg mass మనం తీసుకుంటే దాని తాలూకా వాల్యూమ్ ఇచ్చేస్తాడు. Content in a cylinder behind the piston expands reversibly to a pressure of 0.6 bar. According to the law, P equal to C by V square, where C is constant. Calculate the work done by the fluid on the piston. Work done by the fluid on the piston. Okay. Note down the given data. First, a fluid is at a pressure of 3 bar. Okay. P1 that is given. P1 equal to 3 bar. Okay. Next, specific volume. Okay. And V1 is equal to 0.18 meter cube per kg. Right? Next, content in a cylinder behind the piston expands reversibly to a pressure of, that means P2 equal to 0.6 bar. Due to the expansion, the pressure will decrease. Right? Governing equation for pressure P equal to C by V square. Okay, where C is constant. Calculate the work done by the fluid on the piston. Right. Now W equal to integral P dV. We know within the limits of V1 and V2. Okay, V1 is given in the problem. Okay, and V2 is not given. Next, P1 is given in the problem. Right. And the equation P equal to C by V square, that is also given. But C is not given. See how we can find. Okay, C equal to P V square. Okay, that means P1 V1 both are given. Therefore, P1 V1 square you can put like this. Right. P1 equal to 3 bar. 3 into 10 to the power of 5. Okay, V1 equal to 0.18 square. We know. After that, we need to calculate V2 also. Here, by using this equation, P equal to C by V square, that implies V2 square is equal to C by P, P2. Okay, C equal to 3.3 into 10 to the power of 5, 0.18. Okay, square divided by 0.6 into 10 to the power of 5. Okay, right. And it is V2 square, therefore V2 is equal to, okay, this one and this one we can cancel out, and 3 into 0.18 square whole divided by 0.6 under root. Okay, this value will be 0.402 meter cube. Okay, we got V2. Now you can substitute these values, right? W is equal to integral V1 0.18, V2 0.402. Okay, next P, pressure equation you can write C by V square, C by V square dV. Okay, now you need to do the integration. After that you need to substitute the upper limit and lower limit. Okay, C equal to 3 into 10 to the power of 5 into 0.18 square, that is C. Okay, next integration of V square. Okay, that is equal to V minus 2 plus 1 divided by minus 1. Okay, 0.402, here 0.18. Right. Now you need to substitute those values. Okay, here e to the power of minus 1, here it is minus. Okay, now the final answer will be 29.85 kilojoule per kg. Okay, volume is in kg na? Here also this is meter cube per kg. Okay, per kg. This is the work done. Suppose in the problem the mass of the gas is given. If it is 5 kg mass, okay, find the total work. If it is asked, we need to multiply 5 into specific work. It is called as specific work. That means work done per kg. Okay, then we can multiply with 5 kg and that will give total work. Right. Thank you.